Okay, here's another PE HVAC question. So the question states, water flows in a 1.5 nominal Schedule 40 pipe with a velocity of 94.8 feet per minute. A T-fitting splits the flow evenly into two 1/2 nominal Schedule 40 pipes. The flow velocity in feet per minute in each of these 1/2 branches is most nearly what? So let's draw a diagram here. So we have our pipe and it connects to a T-fitting. We know that this is a 1.5 nominal Schedule 40 pipe here. The tricky thing with this is the nominal Schedule 40 pipe. So when this says 1.5 inches, this is not necessarily the inside diameter of the pipe. We need to go to the Schedule 40 pipe and check. So if we go to our handbook and do a Control F to search, we can search Schedule 40. And we can go to Schedule 40 steel pipe. So I'm going to grab this, bring it in. So at 1.5 inches, nominal inches, our inside diameter is 1.6. So it's slightly larger than our nominal size. Thankfully, this gives us our flow area, so we don't need to calculate that. So I'm going to put area 1 equals 2.035 inches squared. And it gives us the velocity at 94.8 feet per minute. So V1 equals 94.8. And before we go any further, this really is just a conservation of mass. So we have our M1 coming in, and then it splits into M.2 and M.2, since these are both equal. So if we set this up, what goes in M1 should equal 2 M2s. We know that this is a 1/2 nominal Schedule 40 pipe. So we know that the flow area is 0.304. So area 2 equals 0.304 inches squared. And we're trying to find V2. So we need to remember that our mass flow equals density times the velocity times the area. And this velocity is in feet per minute, and this mass rate is in pounds per minute. So if we set this up, plug that into there, plug that into here, we know that the densities will cancel out on both sides here. So A1 V1 equals 2 A2 V2. Plug in numbers. So A1 is 2.035 inches squared times 94.8 feet per minute divided by 2 and divided by 0.304. 0.304 inches squared. All this should equal V2. So if I plug that into my calculator, we're left with an answer of 317.3 feet per minute. If we go to our answer, D is the closest answer. So that's our solution.